Hi everyone, today we're going to be talking about topic 3.3, solids, liquids, and gases. So in our previous lectures, we were talking about intermolecular forces, or IMFs, which is going to be a big theme in this chapter. Our state of matter is going to be determined by the strength of those IMFs. And so stronger forces bring molecules close together. And therefore, weaker forces will bring them further apart from each other and make something like a liquid or a gas. And so if you have really strong IMFs, you might expect to have something like a solid. If you have weak IMFs, you're more likely to have something like a gas. And something important to remember is that kinetic energy keeps molecules moving, which also keeps them apart. One important thing to remember is that kinetic energy is proportional, or at least some way related, to temperature. And so solids will have strong IMFs holding them together. They have a limited particle motion because they're so closely packed together. But they can still undergo some vibrations, and so they can vibrate. And so we have two types. We have crystalline solids, which are orderly packed. And some examples are like table salt, right? NaCl. Ice is crystalline, right? And so crystalline solids are typically pretty hard. And then we have amorphous solids, which are unorderly packed or non-orderly packed. And so some examples, or one example is rubber, right? Rubber is still a solid, but you can kind of stretch it. You can pull it. It's not really a hard crystalline solid, something like table salt or ice. Liquids, on the other hand, are still tightly packed. They take the shape of their container, right? That's what we learned in our regular chem class. And their particles are constantly in motion. And so the kinetic energy, or Ke, prevents liquids from ordering to become solids. And also, as a result, right, some of the IMFs are weaker than solids. A property that we might already be familiar with is viscosity. And so viscosity is the resistance of a liquid to flow. So a low viscosity means a liquid flows quickly, whereas a high viscosity means a liquid flows slowly. And generally, higher IMFs equal high viscosity. which makes sense, right? If we have particles interacting more with each other, they're not going to want to move around as much. Another property of liquids that we've encountered in our everyday lives is surface tension, which is the ability for water to interact with itself and form almost like a skin. So this causes water to bead up on a nonpolar surface. Right, and so if I have some sort of a non-polar surface here, let's say like, a little penny, and so I'll have copper, right, copper metal, and then I'll have some water on there. What will happen is the water will sort of bead up and form this little skin, and it won't flow outward kind of off the penny. And so this ability to form a bead and kind of interact with itself is known as surface tension. Another important property of liquids that we often think about in chemistry is capillary action. And so this is the ability of liquids to rise up narrow tubes. And it's kind of dictated by two forces. The first is adhesion, which is the attraction between a liquid and a surface, say like the walls of a pipette, and cohesion, which kind of dictates what we were just talking about in the last slide with surface tension, but it's the attraction of liquid to itself. All right, and so if we think of these two substances here, water and mercury, water has strong adhesive forces. So it kind of crawls up the walls of glass, and if you kind of put a pipette up to it, it would creep up the walls of the pipette. And mercury has strong cohesive forces. So in that case, the mercury would not want to crawl up the side of the glass. The last of the states of matter that we're going to talk about in this video are gases. And so gases are constantly in random motion. Their motion depends on a few things. So motion depends on a few factors. One is temperature. Right? As temperature, or T, goes up, our kinetic energy, which is our motion, or speed of our motion, also increases. As pressure goes up, this decreases the spacing of particles, and so they're closer together. And for volume, as volume goes up, this increases the spacing of particles. Right? If you have more volume, those particles can move around a lot more. We must remember, for gases, particles are always constantly in motion. And for gases, IMFs are very weak. Right? And so they're not really attracted to each other. They're constantly moving around. If we remember from our chemistry class, these have an indefinite volume and shape. And here's just kind of an overview table of the characteristics of solids, liquids, and gases. There's just one thing I want to add to this, and that this has high, or I should actually use the word strong, IMFs. Liquids have weaker IMFs than solids, but more than gases. And gases have very weak IMFs, and it's these the strength of these IMFs that determine a lot of the properties of these states of matter. We'll talk a little bit more about this in class, but for now, that's it, guys. Thanks.